Welcome to Sundar's lecture. This is lecture number 30, and in this lecture we are going to see realization of one flip-flops using other flip-flops. What we are going to do in this topic, we are going to get the outputs of some other flip-flops with the other flip-flop. Right? That is the today's topic, and in that we are going to see first SR flip-flop to D flip-flop. What in sense we are having the SR flip-flop with us, but we need to execute the D flip-flop's performance by using the SR flip-flop, and how we can realize those kind of things we will see today, and in successive classes we will see one by one. SR flip-flop to D flip-flop, SR flip-flop can be acted as T flip-flop, XR flip-flop can be acted as JK flip-flop. The procedure is same for all the flip-flops. Whatever the procedure we are seeing today, that is going to be implemented in all other realization of other flip-flops, right? So what are all the topics we have seen in the previous class? In the previous class we have seen what is the raise around condition in the JK flip-flop and how we can avoid the raise around conditions, right? That is a different topic now. Now we have entered into a different topic, right? So how we are going to realize this one? See, now we are going to realize the D flip-flop. We are going to give input as D, that means 0 or 1, and we are having SR flip-flop with us. Now this SR flip-flop has to work as D flip-flop. So for that what we need to do, first step number 1, maybe I will put it as A, you have to get truth table of D flip-flop. Truth table of D flip-flop, that is what we have got here, and the next step you need to get the excitation table of SR flip-flop. This one, see what is the flip-flop we are having with us, we have to take the excitation table, and what is the flip-flop we are going to build, we are for that flip-flop you need to take the truth table, right? So that is what we have done here. So from this what we need to do, that is the next step. Step number 3, first 2 steps we have done here. We have just taken the truth table and the excitation table. Now this one, this is the conversion table. This is the conversion table that we need to form by ourselves. Now let us form that conversion table. Maybe we will form here conversion table, right? So in this I will draw the diagram and I will show you, right? Now see here, I have just drawn the conversion table here, and what we need to do here, see, first we need to take the input, that is D, we are going to give as the input now. So what actually we are doing now, so we have SR flip-flop. See here, I will just explain you in easy terms so that you can easily get the point. We have now SR flip-flop with us. This is now Q, and this is now Q, and this is now Qn bar, right? Now what we need to do, we have now D input here, only D input, right? Only we have D input, and we need to give this D input to get Qn and Qn bar. Can you understand? We have this SR flip-flop, but what I am going to do, I am going to give only D as input. This D input, if I am giving here 0, the Qn should become 0. If I give 1, Qn become 1. That is our idea. That is the D flip-flop working, right? So that output we need to get from this combination, but with the SR flip-flop. That is the idea. So for that, what you do, you just take this truth table directly here, 0, 0, 1, 1, and this is 0, 1, 0, 1, straight away. No, you don't need to change anything. Straight away you take this values. That is the D flip-flop. You can straight away take the values. No changes. And also Qn, I will put it in a different color. this will be 0, 0, 1, 1. Right? This one we know, right? Anyhow, right? Just I have taken the truth table here. And now this SR values has to be derived from this Qn and Qn plus 1. So if, for that you use this excitation table now. So how will you use this excitation table? We know that when Qn is 0, if it is going to become 0 again in Qn plus 1, that is present state is 0, next state is also 0, then the value of S should be 0 and R should be X. We know this one and we have to do that one here. So if it is 0, 0, what should be the SR value? It is 0x. It is 0 and this should be X. And if it is 1, 0, 1, 0, if it is 1, 0, what should be the value? It is 0, 1. So it is 0, 1. And if it is 0, 1, if it is 0, 1, what should be the S value? It should be 1, it should be 0. So this is 1, this is 0. And if it is 1, 1, what should be the S value? It is X, it is 0. It is X, it is now 0. Can you understand what we have done? We have just taken the truth table of the D flip-flop straight away, and with the help of the excitation table, we have just derived the values of S and R. That's all. Very simply, right? So you have to remember these kind of things. This procedure is common for all other flip-flop conversions. So you please be very careful by listening to this one, because this helps you in all other flip-flops, right? So now what we have done, we have just derived the conversion table, right? For next step, it is also very important. Now the number 4, maybe I have taken it as D, C. Now I will take D now. What is the D step now? Derive the expression for S and R using D and Qn inputs. Qn inputs. Use, I am giving hint here, use K-map. Use K-map. What this one exactly means? Since we have S and R inputs here, we need to derive the expression so that we can draw the diagram, draw the logic diagram simply, right? For that, what we need to do, we need to use the Karnaugh map. How will you use the Karnaugh map? That is the next question. So D and N, D and Qn, I have told you here, right? So what you need to do now, this is the input now, this is the output. Let us assume, maybe I will just write it down, K map for S output. We always draw the K map for each output, right? Now we have S and R as the output, not taken as input. So try to understand, we are deriving the expression for S and R with the help of these two inputs, right? You don't see this one, don't see this one. Qn plus 1 will be eliminated after writing the S and R values, right? So how will you draw the Karnaugh map? Right, I will draw the Karnaugh map and I will tell you. Right, now you see here, I have just drawn the K map. So this is D and then Qn. So for 0, 0, for 0, 0, what is the S here? It is 0. So it is 0 here. For 0, 1, what is the S here? It is 0. For 0, 1, what is the S here? It is 0. For 1, 0, it is 1. For 1, 0, it is 1. For 1, 1, it is X simply. That's all. So how will you simplify this one now? You have to cover all the ones. So how will you cover all the ones now? Simply these two can be made as pair, right? Only possible. It can be made as pair. So if it is pair, so the equation will be for S. S will be is equal to what I have to write here. So this is pair. So straight away I have to write this one. So there is no common term in these two. So D bar is the answer for S. Can you understand? Very simple, right? So next one, and this one for 0, 0, what is the value of R? It is X here. For 0, 1, it is 1. For 1, 0, it is 0. For 0, 1, 1, it is 0. So again, simply if you just make the pair of these two, right? These two will be taken as pair, and what should be the value of R now? So straight away, 1 minute, I have made mistake here, right? So this is D bar and this is D, made mistake. here here. So actually this is a D bar, this is D bar, and this is D. So what will you get here? This is D, right? So I made a mistake. Anyway, see here, this value will be now, it is D bar, simply. Right. Now what we will do? We will draw the diagram straight away. See here, I have SR flip flop with me now. This is the SR flip flop. This is the SR flip flop I have with me now. So I will just write this as now S, this as now R, and this is Q, and this is QN bar. This is QN, and this is QN bar. And what I am having here, this is my D, this is my D, right? What I have to do now? So D can be directly connected to S. So D, that can be directly connected to S. See here, simply. And R should be D bar now. R should be D bar. Put a different color here. R should be D bar. Put a NOT gate here. Connect it to R now. Connect it to R. And you generally make this as like this. So this one can be given to clock pulse, right? This is now clock pulse. So now you see here, I have SR flip flop with me now. This is SR flip flop. But what I can do now, if I give 0, this QN will become 0. If I give 1, this QN will become 1. This QN will become 1. Right? Now I can use this SR flip flop as a D flip flop. As a D flip flop. Can you understand? This is the idea. This is the idea. See what I have told you in the beginning. What I have told you in the beginning. Okay, now this is E, step number E. Maybe I have missed it out. Draw the logic diagram. Draw the logic diagram. So this is what I have told you. So you see here, I will just explain again one by one. So we are going to see now realization of one flip flop using the other flip flop. In that we are going to see SR flip flop to D flip flop, which means we have SR flip flop and we are going to convert that into D flip flop. First one, draw the truth table of the D flip flop. Whatever the flip flop you are going to convert, you have to take the truth table, and whatever the flip flop you are having, you have to take that as the excitation table. That excitation table has to be taken, and we need to draw the conversion table with using these two tables now. So how will you draw that one? Take the truth table of D flip flop directly and put the values here, and this flip flop SR value should be derived using the excitation table. Using the excitation table, and you need to take the values and put what is the value you will get for S and R if Qn and Qn plus 1 are these values. And what is the next one? Now we need to derive the values of S and R in sense of D. That is what we are actually doing. That is why I am not told you here anyhow. So what we have actually done here, we have just derived the expression for S separately, R separately with the help of only D and Qn, which means we are going to get it as D now, right? So even if you are getting with Qn, no problem, you can get it from here. You can get it from here, right? So that is what we have done here. And step number 4, we have done this one. S and R equations has been derived, and step number E, that is we are going to draw the logic diagram. This is the SR flip flop, and we have to give the input as D, and we have just done here, right? So there are 5 steps, and you need to follow the 5 steps to get the conversion, right? So what we will do now, we will take the other 2 examples now. right? Now you see what is the next one? It is SR flip flop to T flip flop. Now we have to convert the SR flip flop into T flip flop. So how will you do this one? So first you have to take, okay, here we need to take the T flip flop truth table. We have taken T flip flop truth table, excitation table of the ASR flip flop we have taken, and we need to draw the conversion table. How will you draw the conversion table? And here it will be T flip flop, right? So we have to take this as now T flip flop. So this one you have to take this table exactly here. So this one it is common. Now we have to write down this one. So what is the value here? It is 0, 1. I am just writing this one, 1, 0. That is Qn plus 1, right? Now we need to derive the XR values by using the excitation table. If it is 0, 0, if it is 0, 0, what should be the SR value? It is 0 and then X. If it is 1, 1, what is the value? It is X and then 0. It is X and then 0. And if it is 1, 0, sorry, if it is 0, 1, if it is 0, 1, maybe I am writing rightly, and no problem. 0, 0 means it is 0x, and then 1, 1 means it is x0, 0, 1 means it is 1, 0, it is 1, 0, and 1, 0 means it is 0, 1, right? So now what we have done, we have just derived this one by using excitation table of the SR flip flop, and the procedure again it will be same here. What is the next step? D. Step number D, derive the expression. Derive the expression for S and R using what is the value? T and Dn. Sorry, Dn not Qn. Same procedure. We need to derive the expressions now. So how will you derive the expressions? Just I will draw the diagram and I will show you. Right. Now you see I have just drawn this one for 0, 0. This is the input now 0, 0. What is the value of S? It has to be 0. It has to be 0. And for 0, 1 it is X. And for 1, 0 it is 1. And for 1, 1 it is 0. Right? It is now 0. So what you need to do here? You need to get any pair or quad or octet possibilities, but here you cannot do anything. So what you need to do, you have to take this as a separate group. So what is the value of this one now? So it is the value for S now. So S will be is equal to, what is this one? It is T, and what is this one? It is Qn bar. So it is T and then Qn bar. This is the expression for S. So what is the next one now? So for R I have to draw the K-map. 0, 0 it is X. So for 0, 0 it is X. For 0, 1 it is 0. For 1, 0 it is 0. For 1, 1 it is 1. See here also there is no possibility, only one possibility. So I have to take this as a separate pair. So maybe group, right? So what is the expression now? For R now, maybe I will write here for R, which is equal to, it is T here, but this is now Qn. It is Qn, right? So what we have done now, we have just derived the expression for Q and we derived the expression for R with the help of T. That is the idea. And Qn, we can get it from the SR flip flop, right? That is what we have done here now. So what is the next step now? We know, right? So we have now T flip flop with us. So this is the T flip flop, right? Sorry, SR flip flop, not T flip flop. This is now S and this is now R, and we know this is Qn and we know this is Qn bar. And what we have with us now? We have T input now with us, right? So this T now has to given to S and R through this equation. So how you can draw the logic diagram? Maybe I missed out the heading here. So it is E, draw the logic diagram, right? Draw the logic diagram. Go step by step so that it will be easy to remember. So what we need to do now? We need to take T input, and then we have to multiply that with the Q n bar. So I have to draw an AND gate here, an AND gate, right? This is my AND gate, and I have to give this input as T here, and I have to take this Q n bar, right? So this Q n bar has to be given to this one through like this. So I have to give like this, right? So now what happens? This has to be given to yes. This has to be given to yes. So now S has been completed. Then what is the next one? It is R. So how will you draw the R? For that also you need to go for AND gate. You need to go for AND gate, and you need to get T as one input. So T as one input. What is the next input? It has to be Q n, right? So get the Q n with you. So this has to come to this input here, and this will be connected to R. Now you see, this is the diagram for conversion of T flip flop into SR flip flop. Now this is SR flip flop. What I am having here, I have SR flip flop. So I may write the equations too. I may write the equations. This is T Q n bar. This is T Q n. And this is my T now. So I will get like this. So now we have converted. We have just converted. If you give T 0, then the output will be same. No change. If I give 1, whatever the Qn you have, it will be inverted. That is the idea. It will work. It will work like a T flip flop. SR flip flop can be work like T flip flop. Right? What is the next one now? You can go for SR flip flop to JK flip flop now. Right. Now you see, the next one will be SR flip flop to JK flip flop. Right? We have SR flip flop and we need to convert that into JK flip flop. The same procedure. Truth table of the JK flip flop I have taken, excitation of the SR flip flop I have taken, and the conversion table. Right. In the conversion table, what I need to do? I need to write the, maybe I will just zoom it down so that you can easily see this. Right. So you please make this one, because I need to show you this. So I have taken like this now. So now this table I have just taken here. Maybe I've just take this table I have just taken here. Now I need to derive the values for S and R using this one now. So how will you do that? If it is 0, 0, what is the value for S? For S and R, it will be 0 and then X. And if it is 1, 1, it is X0. It is X0. And if it is 0, 0, if it is 0, 0, it is 0X. It is 0X. If it is 1, 0, 1, 0 means it is 0, 1. It is 0, 1. For 0, 1, it is 1, 0. It is 1. Here it is 0. For 1, 1, it is X0. It is X. It is 0. For 0, 1, it is 1, 0. 1, 0. It is 1 and then it is 0. And for 1, 0, it is 0, 1. Right? So now what I have done here? I have just drawn the conversion table. Right? Now this is the conversion table. And with the conversion table, what I can do now? I can go for the K-map. So here it will be 3 variable K-map, right? So J, K, Q, N. We have to derive the expression for S and then R using J, K and Q, N. That is our whole idea, right? So I will just put the K-map and I will show you. Right? You see here, I have just drawn the K-map for S and then K-map for R here. So we need to derive these two expressions using JK, QN. That's what we need to do. So 3 variable K-map. Here it will be 3 variable K-map. From where I need to get the values? For S, you see here, from here, see here, I need to write this one. So this will be, in min terms, this will be 0, 1, 2, 3, 4, 5, 6, 7. You know those kind of things, right? So I can straight away take these values and put it in the R. Maybe 0, 0, 0, S value is 0. For 0, 0, 1, S value is X, right? So I will just put those values in the next slide and I will show you. And you see, I have just uh, put all the values here. Now I need to simplify this K-map. How will you simplify? I need to cover all the ones. So is there any octet possibility? No. Quad possibility is there? No, right? There is no quad possibility. Only I can go for pair. So how I can do this one? I can take these two ones as one pair, right? That is the value of S now. So I can write straight away S will be is equal to this J is a common term and this J, and what is the common term in these two now? What is the common term? It is Qn bar. Qn bar. That is the idea. And what is the K-map simplification here? Is there any quad possibility? No, right? Only pair is possible. No quad possibility is here. This pair can be taken out and I can write straight away the value of R, that is KQN. That's all. So now what I have to do? I have to just draw the diagram. So this is the equation we know, right? So how will you draw the diagram? So I have SR flip-flop with me. I have SR flip-flop with me now. So this is S and this is R and this is Qn, this is Qn bar, right? So this is, maybe I will write here Qn and then Qn bar. Maybe this is SR flip-flop. Now what are the inputs I am having? I have J and then K simply. So what I can do now, to get the S, I need to multiply J and then Qn bar. For that what I need to do? Simply you put an AND gate here, put an AND gate, what I have to get here? J, I have to get J as one term and I have to get this Qn bar and I have to get this Qn bar as the another term, another input, right? So this is, now I have to give it to yes, right? What is the R now? I have to put another AND gate, right? So this is the another AND gate, and for this one I need a K input. I need K input here. So this is the one input, and what is the another one? It is Qn, right? So from here I need to get it down. I need to get this. I need to get this one. So this one. So what is this one now? Simply, this is now the input for R. This is now the input for R. Now, what is the expression? I can also write the expression. This is JQN bar and this is KQN. And now, I can give the input as 0, 0. If it is 0, 0, then the output will be no change. If I give 1, 1, the output will toggle now. In SR flip-flop, there is no toggle possibility. But now it will happen. Because I have just converted this SR flip-flop into J flip-flop. Like this, you need to convert the SR flip-flop into J flip-flop, and this is the E logic diagram, right? So and now we have just done all the things, and what are all the topics we have seen in this class? So we have started with the realization of one flip-flop using the other flip-flops, and in that we have started with the SR flip-flop to D flip-flop. What is the steps we have? We have just 5 steps. One is truth table of the flip-flop which we need to convert, and the excitation of the flip-flop which we are having with us, and then with the help of these two tables we need to derive the conversion table. And what is the conversion table? And in conversion table we need to put the truth table of the flip-flop which we need to convert, and then we need to derive the expression for S and R from the excitation table. And we need to simplify the expression to get S and R using K-maps, and then we need to draw the logic diagram. And we have seen SR flip-flop to T flip-flop, and finally we have seen SR flip-flop to JK flip-flop, right? That is what we have seen in this class. We will see in the next class. Thank you.